Hello students. Today we are going to discuss about a topic called language of chemistry, which is in 9th standard of ICSE. So let's begin. So first of all we are going to start with element, right? We are going to start with element. So elements are the element, right? Element are the simplest form of matter, right? Simplest form of matter. These further cannot be broken down into more simpler form. More simpler form. We also can say these are the fundamental substance, right? These are the fundamental substance. And we can say elements are composed of very tiny particles, very tiny particles called atom, right? Called atoms. Okay, very tiny particles called atom. Let's understand. Suppose this is a piece of gold. I hope you know about the elements. We have 118 elements, so it is not an issue to discuss or to start with gold, because this is very familiar element actually. So let's divide this gold into 2, 3, 4 any number of pieces, and I'll ask you to take one piece of it. Suppose this is the piece that you have chosen, and I'll ask you what is this. Definitely you'll say it is a gold. It is a piece of gold, right? So when you reach to a certain level, that you can find a tiny particle which is not visible to us by naked eye. But how I am saying that this is a tiny particle? Because we have sophisticated equipment that can show us how an atoms look like, right? How an atom look like. Okay, so this tiny particle is called atom. This tiny particle is called atom. Now you can say the element, in bracket I am writing matter, is consisting of tiny particles called matter, right? Tiny particles called matter. Okay, now let's define what is an atom. So as these are the tiny particle, we can say these atoms, these are the smallest particle of element or matter which may or may not have independent existence. Independent existence, right? And these can take part in any chemical reaction. In any chemical reaction. So this is what the definition of an atom is. Okay. So atoms are the smallest particle, and these can take part in any chemical reaction. So these small particles constitute an element, right? This small particle constitute an element. Now let's move on to next page, and we'll start with the symbol of element. Symbol of element. So what is a symbol actually? Symbol means the shorthand representation. Shorthand representation. Shorthand representation of an element Now let's understand with a very funny example. Let's say this is a student, okay, always smiling. His name is Ram Prasad Das. Okay, his name is Ram Prasad Das, but no one calls him Ram Prasad Das. Okay, all of his friends call him by his nickname that is called Papu, right? Papu. It is not that Papu, it is Papu. Okay, so it is Papu. That means this particular student or the boy is very much known by its nickname that is called Papu. Why? It is easier to remember than Ram Prasad Das, right? Similarly, we have 118 elements, right? We have 118 elements, and it is a difficult task to remember the names of the all the elements. Okay, to remember the names of the all the elements along with their actual spelling and pronunciation to, or whether they will be taking part in chemical reaction, it will be a very difficult task to write always their full name. Instead, to avoid such problem, scientists have discovered the symbols, right? Scientists have discovered the symbol. Let's say I'm not going to discuss about who has discovered and so on things. As I told, our chapter will be very precise and crisp, right? Let's say hydrogen. Let's say hydrogen. The symbol for hydrogen is H. You know all these things. Again, I'm telling. Oxygen. So the symbol of oxygen is O. The symbol of calcium is Ca, right? So these are the symbols of different various elements, right? Understood? So now let's understand what is the significance of this symbol. Significance of the symbol. Significance of the symbol, right? So the first and important significance is this symbol represents one atom of the particular element. The particular element. It also represents mass of one atom of the particular element, right? Particular element. So this is what the significance of symbol. Basically, this first point is very important. The symbol represents one atom of that element. If I ask you, let's say for chlorine, Cl. So what do you understand by chlorine? That means one atom of chlorine. Okay, one atom of chlorine. Similarly, let's say for nitrogen, what do you understand by this? One atom of nitrogen. One atom of nitrogen. Hope you understood this concept. Let's move on. So after symbol, let's understand what is the valency of an element. What is the valency of an element? To understand the valency of an element, we need to know about the structure of element, right? So let's say this is an atom and these are the cells of the atom, right? So the central part is called nucleus. The central part is called nucleus, and inside this both proton and neutrons are there. Both protons and neutrons are there, which comprises the mass number of an element. Mass number of an element. and in the cells electrons are moving, and in the cells electrons are moving, okay, with certain amount of energy. Electrons are moving. So from this we can say that an atom is, or an atom consists of the subatomic particles called electron, proton and neutron. Okay, electron, proton and neutron. Clear? So now the most important subatomic particle here is electron, because the property of an element depend on electron only. The property of the elements depend on electron only, because there may be loss of electron, there may be gain of electron. Okay, because for every element, for every atom, if there won't be any combination, there is not, or there will be no chance of formation of any compounds. Hence electrons are very necessary and important particles of an atom or element, right? So now let's understand the arrangement of electrons in the cells. Arrangement of the electrons in the cells, right? So elements are arranged according to the octet or duplet format or structure. Duplet format, that is, we have four cells like K, L, M and N. Okay, so in first cell there will be 2 electrons, second cell there will be 8 electrons, third cell 8 electrons and fourth cell 8 electrons. And this kind of electronic configuration is applicable till the atomic number 20. Okay, more than 20 there is a different method, so we'll be learning that in higher classes, right? So the atomic number up to 20 will have the electronic configuration like this. Now let us do one by one. Again, I am not telling all the things like who has told this Bohr-Bury scheme, representation of electron. Those things you know in the previous classes, in junior classes you know that. So now we are talking about the precise points, right? So now let's write the electronic configuration for, let me write here K, L, M and N. For hydrogen, one more important concept. Okay, how to identify, first of all let's understand how to find out the number of electrons, right? How to find out the number of electrons, right? देखो, there is a simple concept called atomic number, which is represented by Z, is equal to number of protons, which is represented by P, is equal to number of electrons, which is represented by E minus. Okay, and how to know this atomic number? The atomic numbers are basically the serial number of the elements, right? Serial number of the elements. Okay, so if I say the atomic number of hydrogen is 1, how many electron it will have? 1 electron, so we'll put 1 here. Similarly for helium, how many electron it is? 2, so 2 electron. For lithium, the atomic number is 3, that means it has 3 electrons, so first cell 2, second cell 1. Let's say for calcium, the atomic number is 20, that means it has 20 electrons, so first 2, then 8, then 8, then 2, right? Similarly, you can draw the electronic configuration or write the electronic configuration of the element. Why it is necessary? because from this electronic configuration only we'll be able to find out the valency of the element, and also we'll be able to find out, or we'll be able to convert the atoms into it ions. So to know or to understand this electronic configuration is very necessary. Hope you understood this concept, and you will write the electronic configurations of hydrogen to calcium. Okay, that will be your task, right? So now move on to how to find out valency of an element. Okay, how to find out the valency of an element. Okay, before that let's understand about this thing. So if this is the nucleus, these are the cells, right? These are the cells. I am drawing two cells only. This is the nucleus, and this last cell is called valence cell, is called valence cell, right? This is also called outermost cell. This is also called outermost cell, right? So the valence electron, in valence electron, the number of electrons are present will be called as, in valence cell, the number of electrons are present will be called as valence electron. Valence electron, sorry for the mispronunciation. It's called valence electron. So the valency of an element depends on these valence electrons. Let's understand. Suppose an atom has valence electron 1, 2 and 3, and 4, 5, 6 and 7. I am not writing 8 because if there will be 8 electrons in the outermost cell, they will be considered as the stable element or inert element or inert gases. So they don't react with any other element. Hence, we are not going to take 8, right? So in this case, you see the number of electrons are 1, 2 and 3. If I ask you what will be the valency of these elements, you will simply say 1, 2 and 3. Let's say example, let's say for lithium. So the electronic configuration is 2 and 1. So how many electrons are there in valence cell? 1. That means the valency will be also 1. If I say for aluminium, the atomic number is 13, electronic configuration is 2, 8 and 3. How many electrons are there? 3 electrons, 3, right? So the valency is also 3. And why this? When, dekho, it's a very important concept now. And why this? Because when 1 or 2 or 3 electron will be there will be loss of electron. There will be loss of electrons, right? They will easily lose the electron, or they will lose the electron to get the inert gas configuration. Okay, to get the inert gas configuration. This 2, 8 is the electronic configuration of neon, and this 2 is the electronic configuration of helium. Hence, to attain the nearest inert gas configuration, some elements lose electrons, right? Some elements lose electrons, and in this case these are metals, right? These are metals. So I can write for aluminium ki 13, okay, that means minus, as it is 3 electrons are there, so there will be loss of 3 electron, and it will gain 3 positive charge, right? Similarly, if I am writing for sodium, so 11 means 2, 8 and 1, so there will be loss of 1 electron, so minus 1 E will give you Na 1 plus. Understood now? So this is how you can find the valency, and also you can convert an atom into its respective ion. Clear? Now let's move on to the number of electron, or the valence electrons are 4, 5, 6, 7. Dekho, when it is 4, 5, 6, 7, we have to convert them into 8. Now you can understand, if it is 4, that means 4 electrons needed to make it 8. For 5, 3 electrons needed to make it 8. So when you find 4, 5, 6, 7 in the valence cell, 7 number of electrons in the valence cell, there will always be gain of electrons. There will be always gain of electron. Let's say for oxygen, the atomic number is 8. If I write the electronic configuration, it will be 2 and 6. That means it requires 2 electrons to become, or to get the nearest inert gas configuration. Okay, so that means it requires 2 electrons, means the valence will be 2. Similarly for chlorine, this is 17. So 2, 8 and 7. So how many electrons it need? It needs actually 1 electron. So the valency will be 1. Okay. So similar for nitrogen. Nitrogen is 7, that is 2 and 5. So it needs 3 electrons. So the valency of nitrogen will be 3. Right. One thing you observe, as I told, the arrow mark is in this side. That means these are added to their cells. These are added to their valence cell. These are added to their valence cell. So now let me write for oxygen. The electronic configuration is 2 is 6. That means it requires 2 electrons. So it will accept 2 electron and it will be acquiring with, or it will acquire 2 minus charge. That many addition of electron, that many number of negative charge will be there, right? And for nitrogen, it is 7 means 2 and 5, so it requires 3 electrons, so it is 3 minus, then and 3 minus. Understood? So this is how you can convert an atom into its ion, right? I hope you understood this concept. Now next move on to the next one. Radicals. Now let's understand, okay, radicals, right? Radicals. Next understand now the term called radical. देखो, radical, first of all let me define what are radicals. Radicals are the single or group of atoms having charge on it and behaves as a single unit. Okay, behaves as a single unit, right? So it just said कि single or group of atoms. Okay, so now let's divide this. Acha. First of all, single atom. Single atom means that is called simple radical. Simple radicals. These are also called ions. These are also called ions. Okay. And another one is your complex radical. Complex radical. These are also called compound radical. Compound radical. Okay. Compound radical. Now let's understand. Simple radical means a single atom with charge. A single atom with charge. So some element will have positive charge on it, some element will have negative charge on it. So the positive charged particles or radicals are known as cations and the negatively charged particles are known as anion. Okay, cation and anion. So let's say Na plus, this is cation, O2 minus, this is anion, Ca2 plus cation, Fe3 plus, Cl1 minus anion. Okay, so this is how you can differentiate between cation and anion by looking at the charge on it. Now let me define ions once more. The ions are the charged atoms. This is very simple. Ions are the charged atom. Hope you understand this. Now let's go to complex radical. You see, again there are positive one and negative one. Let's say NH4 plus. So there are 5 atoms, yes or no? So this is a group of atoms, and let me write here CO3 2 minus, again group of atoms, but this is with negative charge, this is with positive charge, right? So the positive charged radicals are called electropositive radicals. Electropositive radical, and these are called electronegative radical. Okay, electronegative radical. These are also called basic radical, and these are also called acid radical. We can also say this case, these are also called basic radicals. Why I am writing this, I'll tell you, just wait. Basic radical, and this is acid radical. Okay, now let's get into this. Let's define it little bit more, like these are also I have called radicals, and these are also called radical because it is mentioned here is single or group of atoms, right? Single or group of atom. But when you're talking about ions, these are only atoms, right? These are group of atoms. So I can say radicals can be both ions, or you can say radicals can be of both single or group of charged atom, okay. So this is what the term radical means.